Hello students, in this lecture also we'll continue with the addressing modes of 8085 microprocessor, and then I'm going to tell you about the classification of 8085 microprocessor based on the length of the instruction or size of the instruction. Continuing with the addressing modes. The next addressing mode is the indirect addressing mode. I have discussed three of the addressing modes, that is immediate addressing mode, register addressing mode, and direct addressing mode. So the next addressing mode is indirect addressing mode, or you can say it's indirect addressing mode. So in this mode of addressing, the address of the operand is specified by a register pair, and the other one mentioned in the instruction is also a register. For example, LDAXB. What this instruction does, it loads the accumulator. It loads the accumulator with the content of memory location pointed by BC register pair. Again, I am saying here the operand, we all know operand gets stored in the memory having some memory location. We all know the operand gets stored in the memory having some memory location, and that memory location is stored in some register pair, and we specify that register, name of the register, in the instruction. So any instruction where the address of the operand is specified in terms of register pair will fall under this category, that is indirect addressing mode. I've given another example also, that is MOV A, where the memory data addressed by HL pair is moved to A register. That is the content, that is the operand. The address of the operand is pointed by HL pair, so that operand is going to get moved to the register A. So again, we have the opcode and we have the register pair. Here the register pair is in terms of, we have mentioned the first register, like I've already told you when I was teaching you the architecture part, that the general purpose registers of 8085 microprocessor can function as 8-bit also, can store 8-bit data also, or it can store 16-bit data when it is going to work in pair. So here register pair means, when I'm writing B, it means BC. So B register will store 8-bit data, C register will store 8-bit data, and both B and C will store the 16-bit data. So the 16-bit memory location or the 16-bit address of the operand will get stored in the register pair in this type of instructions. So this is how we specify the operand in this addressing mode. The next addressing mode is implicit addressing mode. So in implicit addressing mode, there are certain instructions which operate on the content of the accumulator. These instructions do not require the address of the operand. Example, CMA, RAL. What is CMA? That is complement the content of the accumulator. So any instruction where we do not have any operand or we do not have any address or register mentioned along with the instruction, those type of instructions will work only on the content of the accumulator and will fall under this addressing mode, implicit addressing mode. So up to this we have the 5 addressing modes. Now we'll go to the next slide where I'm going to discuss about the classification of 8085 microprocessors based on the length of the instruction. So according to the size of the instructions, we have 3 classifications. We have 3 distribution: 1-byte instruction, 2-byte instruction, and 3-byte instruction. So what is 1-byte instruction? A 1-byte instruction includes the operand and opcode in same byte. these type of instructions can occupy only one memory location. For example, as I've told you that MOV A comma B instruction, MOV A comma B instruction, that is MOV A comma B instruction has the opcode. I've told you that the opcode of this instruction is 78H. H is written in the hexadecimal format. So what does this instruction do? It moves the content of register B to register A, and 78H is the opcode of MOV A comma B. So besides the operation to be performed, this opcode 78H also specifies the registers which contain operands. 78H not only specifies the operation, it also specifies the register which contain the operands. For example, let me be more clear. This opcode 78H can be written in binary form as 0, 1, 1, 1, 1, 0, 0, 0. So the first 2 bytes of this 78H can be written in this binary form. So the first 2 bits of this binary number, this 8-bit binary number, the first 2 bits are for MOV operation. It will tell you to move the content from register B to register A. Or you can say it will tell the microprocessor that to move the content from some register, from source register to another register. Now what is the source register and what are the destination registers will be decided by the other bits of this binary number. So the next 3 bits 1, 1, 1 will tell about the destination register, that is register A. They are specifying register A. And the next 3 bits 0, 0, 0, they are the binary code for register B. So in 1 byte instruction, both the opcode and operand get stored in 8-bit, or you can say 1 byte opcode only. The opcode all specifies the operation as well as the registers where the operand is located. So when you're going to store, when you've written the program where you have an instruction MOV A comma B or 1 byte instruction, when such type of instructions get stored, as we know, all the program gets stored in random access memory. We have memory where we have number of memory locations, and each memory location is of 8-bit. Each memory location is of 8-bit, and the address of the memory location is of 16-bit. Again, I am repeating, each memory location is of 8-bit and the address of the memory location is of 16-bit. So what happens? That memory location, when you're going to store the 1 byte instruction in the memory, it will occupy only one memory location. This instruction will occupy only one memory location or only occupy 1 byte. So those instructions which are of 1 byte, they will come under this category. I'm ending this lecture here. We'll continue with the same in the next lecture.